Lunar swirls are bright, curly features on the moon's surface, visible even through a backyard telescope. Some people think they resemble brushstrokes on an abstract painting. However, these are not mere artistic decorations. NASA images show that some lunar swirl streaks extend for hundreds of kilometers. Lunar swirls defy easy explanation, but recent modeling and spacecraft data shed light on this curly mystery. Data indicates that rocks in the swirls are magnetized, and these rocks deflect or redirect solar wind particles that constantly bombard the moon. Instead, nearby rocks take the hit. Over time, chemical reactions caused by these impacts darken the surrounding rocks, while the swirls remain bright. So, how did the rocks in the lunar swirls become magnetized? The moon has no magnetic field today. No astronaut or rover has yet visited a lunar swirl to investigate. Michael J. Kravchinsky, an associate professor of Earth, Environmental, and Planetary Sciences in Arts and Sciences at Washington University in St. Louis, said, "Impacts can cause these types of magnetic anomalies." He notes that meteorites regularly deliver iron-rich material to regions of the moon's surface. But there are some swirls we're not sure how an impact could create features of this shape and magnitude. Kravchinsky believes it's more likely that something else magnetized the swirls locally. To test this explanation, Kravchinsky designed experiments. Another theory is that underground lavas slowly cooling in a magnetic field created the magnetic anomaly, he said. The results were published in the Journal of Geophysical Research, Planets. Kravchinsky and the study's first author, recent PhD graduate Yuanyuan Liang, investigated different combinations of atmospheric chemistry and magmatic cooling rates to see if they could create a magnetization effect in a mineral called ilmenite. Earth rocks magnetize easily because they usually contain small particles of magnetite, a magnetic mineral, Kravchinsky said. Most terrestrial studies that focus on things containing magnetite do not apply to the moon, which lacks this hypermagnetic mineral. However, Kravchinsky and his team found that ilmenite, abundant on the moon, can react to form iron metal particles, which can magnetize under the right conditions. Liang noted, "Smaller grains we studied generated stronger magnetic fields because their surface area to volume ratio is larger compared to bigger grains. With more exposed surface area, it's easier for the grains to enter the reduction reaction. Our analog experiments showed that we can create the magnetizable material needed under lunar conditions," Kravchinsky said. Thus, it is plausible that these swirls originated from underground magma. Determining the origin of lunar swirls is key to understanding the processes shaping the lunar surface, the history of the moon's magnetic field, and how planetary bodies' surfaces interact with their surrounding space environment. This study will aid in interpreting data from future lunar missions, particularly those investigating magnetic anomalies on the moon. NASA plans to send a rover to the lunar swirl region known as Rhina Gamma in 2025 as part of the Lunar Vertex mission. If you're going to create magnetic anomalies by the methods we described, then the underground magma must be high in titanium, Kravchinsky said. We've seen hints of this reaction forming iron metal in lunar meteorites and Apollo lunar samples. But all those samples are from surface lava flows, and our work shows that cooling underground should significantly enhance these metal-forming reactions. For now, Kravchinsky's experimental approach is the best way to test predictions about how unseen lavas might drive the magnetic effects behind the mysterious lunar swirls. If we could examine this in depth, we could see if this reaction took place, Kravchinsky said. That would be fantastic, but it's not possible yet. Right now, we're stuck at the surface.